Let's face a pretty stark reality here. The power grid resources we need to run today's incredibly thirsty AI-accelerated servers are simply running out. Sustainability isn't just some corporate buzzword anymore. It's become a massive physical barrier to scale. Because of these intense power limitations and thermal challenges, liquid-cooled data centers are no longer just a nice-to-have luxury. They are the unavoidable, completely mandatory future of enterprise AI.
Welcome to this explainer. Today, we are exploring a fascinating and absolutely critical topic, the lifecycle management of liquid-cooled AI infrastructure, specifically looking at it through the lens of SuperCloud Composer. If you're building a modern AI factory, you really need to know exactly how to manage it, and that's exactly what we're going to break down today.
Okay, let's dive right into this. We've got a really clear roadmap for our journey today. We'll start with the macro-level AI power problem, then shift over to the supercluster paradigm shift. After that, we'll take a look inside the NVL72 rack, examine the unified dashboard and telemetry, and finally finish up with scaling AI for everyone. Let's kick things off with Section 1, the AI power problem, and specifically the liquid cooling mandate. So, traditional air cooling, it's basically hit a brick wall. The sheer thermal output of modern AI architecture is just staggering. Now, companies like Supermicro, along with major semiconductor manufacturers like Nvidia, Intel, and AMD, have all come out and publicly declared that moving forward, accelerated servers are going to require liquid cooling solutions. It's quite literally the only way to solve the massive power usage effectiveness, or PUE, and thermal challenges so that these highly complex AI models can actually run efficiently. Think about it like this. Imagine hopping into your car to drive from point A to point B, but your dashboard is completely gone. No temperature sensors, no gas gauge, zero alerts. You'd be driving totally blind, right? Well, running AI models that can take months on end to compute without robust telemetry and tool management is exactly like driving that car. It's a recipe for total disaster. You absolutely must have checks and balances in place. Which brings us to Section 2, the supercluster paradigm shift, a shift in management. Now, what's really interesting about this is the total shift in operational logic. In previous rack creation scenarios, you'd discover appliances one by one. A DevOps admin would find each device and then manually add them to a newly created rack. The supercluster AI rack creation is entirely different. Now, the entire 48U rack, pre-populated with all of its internal configurations, is discovered and combined together as one single living entity right out of the gate. And this is exactly where SuperCloud Composer, or SCC for short, steps in. It essentially acts as that missing dashboard we were just talking about. SCC is a unified tool management system that gives you those vital checks and balances, everything from day zero discovery to day two maintenance, which are required to safely run these incredibly complex liquid-cooled AI superclusters. Let's move right along to Section 3 inside the NVL72 rack and look at its standardized layout. Moving from the software side into the physical, spatial reality of these massive machines, Supermicro has completely nailed this plug-and-play building block approach. If you walk down the 48U NVL72 rack, the layout is totally standardized into 5 distinct quadrants. At the very top, you have the management network switches, which are reserved for SEC and baseboard management controller monitoring. Below that are the power shelves to distribute energy. Then you hit the incredibly dense compute trays, which are heavily interconnected by the next quadrant, the NVLink switches. And finally, sitting at the bottom is the cooling distribution unit. This standardized approach dramatically simplifies all the cabling and allows SEC to monitor the entire cluster seamlessly. And that leads us perfectly into Section 4, Unified Dashboard and Telemetry, focusing on real-time monitoring. So how does a DevOps administrator actually interact with these specific components? Let's start at the very bottom, always located in Rack Slot Unit 1, the in-rack CDU. This is really the liquid cooling heart of the system. Through this SEC dashboard, an administrator gets real-time telemetry on coolant return and supply temperatures, pump states, and valve pressures. And critically, the CDU also features external leak detection sensors. The moment a leak is detected, the system can immediately trigger a shutdown condition to protect the massive financial investment sitting inside that rack. Moving up to the NVL72 compute trays, the computational density here is absolutely wild. Every single tray uses 2 Grace ARM processors and 4 Nvidia Blackwell GPUs. SET pulls in all this telemetry via Redfish endpoint integration right natively from OpenBMC. But what's truly a game changer here is the firmware bundling. This is a hugely requested capability that lets an admin bundle and push firmware updates across the entire NVL72 compute configuration all at once, rather than manually updating piece by agonizing piece. Now, to keep all those compute trays talking and powered up, the rack utilizes 9 NVLink switches alongside some really robust power shelves, manufactured by Lite-On. SEC exposes granular sensor readings and power unit states directly in the user interface. The overarching goal here is simple but incredibly important. Minimize the clicks a DevOps admin needs to access the BMC data. You get all the metadata you need to make fast, data-driven decisions right there in one unified interface. And when it's time to scale up, it's completely seamless. Just like you do with older air-cooled systems, administrators can logically group multiple liquid-cooled NVL72 racks together into pods. So, say you have a cluster of racks dedicated entirely to a specific inferencing application. You can easily group them in sec to create your very own dedicated ChatGPT cloud, managing them all under a single shared workload umbrella. And this brilliantly illustrates why standardization is such a big deal. Because the physical rack layout is totally standardized, moving to the next generation GB200 requires virtually no structural learning curve for your DevOps team. The exact same seamless management, the exact same 5-quadrant layout, it's all fully supported right in SEC version 3.11. All right, let's head into our final section. Section 5, Scaling AI for Everyone, looking at NeoCloud operations. We spent a lot of time today talking about massive, crazy expensive 48U racks, but what if you're just starting out? Just one U. That is a tiny footprint compared to the massive 48U superclusters we just discussed. But for NeoCloud data center operators or startups who want to get some skin in the game without a massive initial capital expenditure, this 1U form factor, the GB200 NVL4, is the absolute perfect liquid-cooled entry point. Because the GB200 NVL4 is a total powerhouse in a really small package. It gives you a much lower investment entry point, sure, but it still packs a massive punch with a 72-core Grace ARM processor and 4 186GB Blackwell GPUs. On top of that, SXS lets administrators extract all the server's component metadata into CSV, JSON, or YAML files. This is absolutely incredible for data mining and forecast planning as a newer organization builds up its AI factory momentum. Oh, and I have to point out this highly practical day-to-day management feature in SEC. If a specific NVMe drive fails, you can turn on something called the nifty UID blink for that exact drive. It instantly identifies the failed component on the physical server, which completely prevents the absolute disaster of a technician walking into the data center and accidentally pulling the wrong drive, like, the one hosting the operating system. It's everyday practical checks and balances like this that make a huge difference. So, what does this all mean for us? The hardware required for enterprise AI is evolving at a breathtaking pace, bringing us unimaginable compute density, but also very strict liquid cooling requirements. But remember, the hardware is only as good as your ability to monitor, update, and protect it. With AI models running for months on end, how will you manage the telemetry and lifecycle of your next liquid-cooled AI factory? It might just be time to rethink your enterprise management toolset. Thanks for joining me for this explainer, and stay curious.